So think about it for a second. How do you actually learn from a mistake? Well, you stop, you think about what went wrong, and then you figure out what to do differently next time. Seems obvious, right? But for an AI, that is an incredibly hard thing to do. Today, we're breaking down a brand new framework called Reflexion that gives AI agents something we can all relate to, an inner monologue, and it lets them learn from trial and error, a lot like we do.
All right, here's what we're going to cover. We'll start with the big problem that's been holding AI back. Then we'll dive into this really clever idea of self-reflection. After that, we are going to look under the hood to see how this whole thing actually works. Check out the pretty mind-blowing results, and then wrap it all up by talking about what this means for the future of AI.
So let's start with the main challenge. If we want AI to be truly smart and autonomous, it has to be able to learn from its mistakes. But the way we've been teaching them to do that, it's slow, it's super expensive, and honestly, it's just not that efficient.
And it's a good question to just pause on for a moment. Why is it that a machine that can crunch billions of data points in a second struggles with something a human toddler can do? That basic process of figuring out why something didn't work and then trying a different way.
And this table just nails the difference. Traditional AI training is basically brute force. The AI just tries something, gets a simple, nope, that's wrong signal, and then has to try again and again and again, needing massive amounts of data and expensive retraining just to learn one thing. But us, we can fail at something once, have a quick little internal chat with ourselves, and figure out the solution almost instantly.
So that brings us to the super elegant solution these researchers came up with. Instead of trying to build some complex new system from scratch, they looked at the most powerful learning machine on the planet for inspiration, the human brain.
I love this quote from the paper because it just lays out the whole idea so perfectly. The goal isn't to go in and rewire the AI's brain by updating millions of parameters. No, the goal is to give it the ability to just stop, think about what went wrong in plain English, and then come up with a better plan.
So here it is. This is the key. Reflection gives the AI that inner monologue. Instead of just a 0 or a 1, a pass or a fail, the model gets to generate its own feedback. It turns this vague little error signal into a really concrete text-based lesson that it can actually learn from.
Okay, so how does this talking to itself thing actually work under the hood? Well, it turns out to be this surprisingly clean, three-part system that creates this nice, continuous loop of self-improvement.
Think of it like a little three-person team working inside the AI. First, you've got the actor. That's the one doing the actual work, writing a piece of code or answering a question. Then you've got the evaluator, who's like a judge, just giving a simple thumbs up or thumbs down. But the real magic, the secret sauce, is the third part, the self-reflection model. When the evaluator gives the thumbs down, this model steps in like a coach and figures out why it failed and what to do better next time.
Let's make this real with an example from the paper. So the actor, in this case it was GPT-4, gets a coding challenge. It needs to write a function to check if all the parentheses in a string are matched up correctly. So it gives it a go and spits out its first attempt.
Next, the evaluator model takes that code, runs it against a few tests, and womp womp, it fails. Now, in the old way of doing things, this is where the AI would get stuck. It would just get a negative point and have to flail around trying something else with almost no guidance.
But this is the game changer. The self-reflection model kicks in and produces this. Look at that. It's this incredibly human-like piece of insight. It doesn't just know it failed, it figures out the precise logical reason why it failed. It realized, oh, I counted them, but I forgot to check if they were in the right order.
And here's the cool part. That little verbal lesson doesn't just disappear. It gets stored in the agent's long-term memory. So the next time it tries the problem, it has its short-term memory, what it just did, but it also has this super important distilled lesson from its past mistake, making sure it doesn't fall into the same trap twice.
So, all of this sounds fantastic in theory, right? But here's the real question. Does giving an AI an inner monologue actually make it better at its job? Well, the results aren't just a small improvement, they are, frankly, a new state of the art. On Human Eval, which is a notoriously difficult benchmark for AIs that write code, Reflexion hit a 91% success rate on the very first try. That is a huge leap forward. It just blows past previous records.
And what's so powerful is what you see in this chart. The standard GPT-4 model, which is already one of the best in the world, gets about 80%. But when you take that exact same model and just add the reflection framework, when you just let it think about its mistakes, its performance skyrockets by 11 points. It just goes to show, we don't always need a bigger model. Sometimes we just need a smarter process.
And this isn't just a one-trick pony for coding.
The Reflexion framework boosted performance across all kinds of different tasks. We're talking a 22% improvement in decision-making in a simulated world and a 20% jump in complex reasoning. This is just a fundamentally better way for an AI to learn.
Okay, let's zoom out and look at the big picture. We've got this new method that makes AI smarter without all the expensive retraining. So what are the key things we should really be taking away from this new self-reflecting approach?
Well, the advantages are massive. For one, it's lightweight. You don't need to do all that expensive fine-tuning. But maybe the biggest deal is that it's interpretable. For the first time, we can literally read the AI's thought process in plain English. We get to see not just what it did, but why it did it, which opens up that black box a little bit.
Now, of course, it's not a magic bullet just yet. The entire system depends on the AI being good at judging its own work. If it thinks it succeeded when it actually failed, the whole learning loop just falls apart. There's also the risk it can get stuck in a rut, just endlessly tweaking a bad idea, instead of having that creative spark to try something totally new.